In this video, we're going to take a look on our first chapter. Sorry, we need to put it on the first slide. First chapter in this book, Elementary Statistics, 14th edition by Mario F. Triola. We'd cover many chapters, but in the very first video, we would take a look on the first chapter, Introduction to Statistics, and focus on the first section, 1.1 statistical and critical thinking. Very important to best way to start studying statistics or to introduce the concept of statistics. So, some key concepts we said in this section we would begin with very few basic definitions, and we consider an overview of the process involved in conducting a statistical study. So this process consists of prepare, analyze, and conclude. Like when we talk about preparation, it's like it involves consideration of the context, the source of data, and sampling methods. But in future chapters, we would construct suitable graphs, explore data, and execute computations required for the statistical methods being used. This book has about 8 to 10 chapters. In some of the chapters, we would form conclusions by determining whether results have statistical significance or practical significance. But statistical thinking in general, if you said statistical thinking, um, it involves critical thinking and the ability to make sense of results. So statistical thinking demands so much more than the ability to execute complicated calculations. So we're going to use a lot of examples, exercises, and discussions to develop statistical thinking skills that are very important in today's world. There are so much we can learn, but at first we need to start learning about data, because when you have data, data is a collection of objects. Data you can collect, the data can be either qualitative, that means non-numerical, qualitative data, quantitative, or it can be quantitative numerical. Qualitative means you expect the answer to be a word. The city of birth, the country of birth, and the middle name of your parents, your first name, your major at school, they are all qualitative. But quantitative data is numerical. Your height, your age, your weight, the number of siblings you have. That's very important. The amount of money you have in a bank account, the amount of money you have in your pocket, the number of yellow M&Ms in a bags, they are all quantitative data. We'll have time to go over it. But now the definitions of data is a collections of objects, or you can say collections of observations such as measurement, genders, or survey response. We have so much we can do say about it. But statistics are also some very few definitions we can do. I want to highlight statistic with S. As you can see, there is an S in statistics. So this word of statistics here is the science of collecting, organizing, summarizing, and displaying data. But if we go with these definitions right here, is the science of planning studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, and interpreting those data, and then draw conclusions based on them. So we're going to use data, we're going to collect it, or you're going to collect data, organize data, work around those data. And then, after you do that, you analyze, you interpret, you summarize, and you display to make decisions about something. But where we would collect those data, remember, we said we have two types of data. So these data, collection of data, when you collect of data, you collect data either from a population, or you collect it from a sample. So, population, as we defined it here, the population is the entire group. When we talk about population, you should see the population as the entire group. But when you talked about, the complete collection of all measurements or data that are being considered, typically a population is the complete collection of data that we would like to make inference about. That means the entire group. If you talk about the schools or population, I mean all students attending the schools, the university, the college, the community college, we call it a population. If we talk about people working in a company, we talk about the population. But if you now want to take a subset of that population, that means a very small group from that population, we call it a sample. So sample, it's a subset of the population. So we can call it subset of the population. When I said subset, you can say is part. Is a part of the population also. So I said subset, or you can say a part. But usually, referring to population, what we do is conducting a census. Like the United States of America do a census every 10 years because the United States constitutions require a census every 10 years. Some factors are affected by census results. Like the reason why they do it, because as you can see as these definitions here, census is a collection of data from every member of a population. So we need to consider the whole group because it's based on that they would proceed with the apportion of congressional seats or distributions of billions of dollars of federal funds to states for transportations, education, and or hospitals, or locations of site for business and stores. So, of course, it's not all the time it would be accurate based, of a lot of important factors, you know, uh, to collect data due to the growing diversity of culture. That's very important to pay attention to that, increase the distrust of the government. Not they don't trust the government with data. Some people would be very afraid of letting collect data. So population is the entire group, but sample is a subset of the population. So we define the sample here as a subcollection of members select from a population. So let's say this is the population. You see, the population can be a lot of people, but the samples can be maybe only two of them. So population here, that's a population, the big group, but the sample is very small group taken from the population. So we call it sample. We're gonna go into review very quick and examples about the population. In a survey of 1,046 adults conducted by Bradley Corporation, subjects were asked how often they wash their hands when using a public restroom, and 70% of the respondents said yes. So all they ask you to do in these examples is to identify the sample and identify the population. So in a survey of 1,046, here they don't tell you if 1,046 is the entire group, but here it's mostly considered as the sample. So sample for us in this case, if you go with the sample would be the 1,046 adults. So that's the one they talk about. That's the small group. But in terms of population, what the population can be, it's the entire group, right? So 1,046 adults were surveyed. That would be the sample. Population, that would be all adults. All adults. Right. So we're going to say the population consists of all adults. But for B, I'm going just to explain what B would be instead of like really writing it down because it would take us too long to do that. They said, would you better results? Would you better result be obtained by observing the hand washing instead of asking about it? Remember, this survey says that they ask people how often they wash their hands. Would you prefer to ask people how often they wash their hands, or would you prefer to sit and observe? So they said, would you prefer to observe or, ask instead of asking them? So what we would say in this case, when asked, respondent might be inclined to avoid the shame of unhealthy habits of not washing their hands. So the report rate of 70% might well be much higher than it is in reality. So it is generally better to observe or measure human behavior than to ask subjects about it. So it's better observe than asking, right? So because when you ask, people will look at you in the eyes and feel ashamed of, oh, he would know that I didn't wash my hands. But if you sit and observe, it would be way much better. So it's better that you observe. So better observe. Yes, better observe than ask. Okay, it's better you ask. You better observe than ask. For number two, we would go back to it because this one talked about the statistical significance and practical significance because that's the topics we would cover. I would let you to enjoy this one because we should now proceed. It's very important to proceed I mean, to consider the process involved in a statistical study. You know, as we said, when we do the statistical study, all right, we should analyze sample data relative to context, source, and sampling methods. So if we do that, then we do the preparation. So we should start with the fact that we need to prepare the data. So prepare include context. What do the data represent? What is the goal of a study? You cannot just take data. You need to understand what the data represent and also what's the goal of the study. Source of the data. Are the data from a source with a special interest so that there is a pressure to obtain results that are favorable to the source? Because we need to review all of this. That's very important. All right. So the second step is in our preparation is to consider the source of the delta, of the data after the context, of course, because we said we should begin with the preparation by considering the context of the data. Then we consider the source of the data. Are the data from a source that with a special interest? But also this third step, we should conclude in our preparation by considering the sampling methods, where the data collect in a way that is unbiased or where the data collect in a way that is biased, so such as procedure in which response volunteer to practice. So very important, is it biased or unbiased? Because some response, people would say, no, it's biased. You take it, you didn't collect it properly, so very important to be very clear on the sampling methods. How do you intend to collect this data? The second step, because as we go through all our steps in our statistical thinking, critical thinking, the second step is to analyze. That's very important to go through analyzing the data. There's, slide 11 and 12 would give you an idea about and examples on where we can do statistical and critical thinking. So with preparation, analyze, and also, conclusion. So, but analyze is, we need to analyze this. We should begin with the appropriate graphs and explore of the data, right? So because graph the data, that's the second step to do because we begin to analyze our data. An analysis should begin with appropriate graphs and exploration of the data, right? And then explore the data. What does that mean to us? It means that are there any outliers? Numbers are very far away from almost all the other data. When we talked about outliers, suppose in a company the average income or the income of most of the employees range from 40,000 to $60,000. Let's say 98% or 99% of employees earn from $40,000 to $60,000. But there is 1% that earn maybe 400,000 per month, maybe the CEOs, or for I don't want to be exaggerated. So 400,000 per year. But you see, most of people earn from 40,000 to 60,000, but a very few people earn over 300,000 or maybe 500,000. So those are outliers. The same way, if there are any ones earn less than 10,000, also we would probably consider those as outliers. So are numbers that are very far away from almost all the other data. We're gonna verify if they when we analyze when we begin with to analyze the data, the first thing we need we should begin with appropriate graph and exploration of the data. Then appropriate graphs, then we need to verify if there is any outliers. What important statistics are summarize the data, such as the mean and standard deviation? So we would cover this in chapter 3, talking about mean variance and standard deviation. We will talk about it later. How are the data distributed? Is it spread out or spread in? Is it shrinking? Is it stretched? So we need to see that. Do we have more data on the left or more data on the right? Is it screwed left, screwed right? Is it symmetric? So we're gonna answer. Those are things we would cover anyway in later sections. Are there missing data? Did many select subjects refuse to respond? So we need to identify anything related to that study that could, reveal some unbiased. Like it should be very clear, very precise. Now, after you do that, later, we would do some application of statistical methods. That's very important to know how to do that. Use technology, for examples. We're going to use a lot of Excels or StatCrunch, or you can use SPSS, or you can use SAS. There are so many different methods nowadays that you can use as technologies to analyze data and obtain good results, like effective results. Now, after we go through to the first two steps. The final steps in our statistical process involve conclusions, and we should develop the ability to distinguish between statistical significance and the practical significance. So that's exactly, remember we said example 2 is about these two. But before we go further, how about we analyze these steps. So what you see here in these examples is a shoe print length and height of 8 mil. So we do that just to explain, in these particular examples. So just that, what they want us to do, determine whether there is a relationship between shoe print lengths and height of males. That's what we're gonna do. The tables include shoe print length and height of 8 mil. So forensic scientists measure shoe print lengths at burglary scenes and other crime scenes in order to estimate the height of the criminal. So the format of the table suggests the following goal. Determine whether there is a relationship between shoe print lengths and height of males. All right. So these goals suggest that a reasonable hypothesis. Males with larger shoe print length tend to be taller. Is that true or false? We are using data for males only because 84% of burglaries are committed by males. So we saw it. It's not a stereotype or something, but we want to make sure that you understand it because it's something that has to do with statistics. We use statistics for that. Now, for this example, so we can also remember the first one is to understand the context because we do some preparations. We understand the context. What are the source of the data? The data in the table are from data set 9 because you need to identify where did you collect the data, the source. Are the data from a source with a special interest so that there is a pressure to obtain results that are favorable to the source? So you need to identify where the data was collected. So in this case, you can find this data in the book in Appendix B, called Dataset 9, where the sources are identified. The source certainly appears to be reputable. Now, the third step when you proceed with preparation, when you prepare preparation, you need to verify the sampling method, where the data collect in a way that is biased or unbiased. So the individuals were randomly select. So the sampling method appears to be sound. That means it should be good. You know, so that means it should be good because the randomly select. All right, now let's go with some examples. In these particular examples, we would just ask you to determine whether the given source has the potential to create a bias in a statistical study. Remember, we said, for the bias, let's go over the examples, and you would see what it is exactly. The American Automobile Association (AAA) is a not-for-profit federation of motor clubs, pools, provides automotive and travel services. First of all, they tell you what this non-profit organization is doing. The AAA conducts a survey of its members about the use of public transportation versus private transportation. Would that be biased or unbiased? Yes, it would be. I mean, there is a potential to be biased because that appears to be a potential to create a bias because you know what? It's not because some people take public transportation, uh, you know, uh, then those people don't have means to use also the private automobiles, right? Now, the second examples, data set one body type, that body data in Appendix B includes pulse rates of subjects, and those pulse rates were recorded by examiners as part of a study conducted by the National Center for Health. So they really take their time to conduct such a study. There are a lot of parameters that they take into account here. So in this case, now we're going to consider this one as a no because they said determine whether the given source has a potential to create bias or unbiased. No, that's unbiased, right? So we can say this one is really unbiased, right? Because it's a very formal, organized study, right? Bias. I think I made a mistake in writing bias. Okay. So two examples, of course, you're going to have a lot of time ahead of you to answer more questions. But in the meantime, let's move with some other definitions because the first section or the first chapter is all about definitions. We would we addressed the definitions of voluntary response sample or self-select sample. Is one in which the respondent themselves decide whether to be included, right? When you receive some, some surveys by phone or by on the internet, voluntary basis response, the following types of polls are commonly examples of voluntary response samples by the very nature, all serious flawed because we should not make conclusions about the population on the basis of samples with a strong possibility of bias. Like, you know, interpret internet polls in which people online decide whether to respond is totally voluntary. You can receive an email or a link and you decide not to click on it. Sometimes it's even a scam or spams. Mailing polls in which people decide whether to reply. When you receive it, there is no requirement that you must fill it out and return it. So it's totally voluntary. Telephone calls in polls. How many times you receive a call, it always says scams likely. So you either ignore it or you hang up right away. So telephone calls in polls in which newspaper, radio, or TV announcements as that you voluntarily call a special number to register your opinion. So we have so many like this that we could do. But for us, let's see what appear to be a sound or flaw at some point. In these particular examples, they're gonna ask you determine whether the sampling method appears to be sound or is flawed. We said if something is really done in a voluntary basis, so we would say it's flawed, right? Anytime it says oh, it's flawed because if it's a voluntary basis, then it's flawed. If it's not voluntary, then it sounds okay. I'm hoping you remember, voluntary basis is flawed and not voluntary basis too. And so, like when it's required, when you leave your house and go to participate in a survey, or you register, you record yourself, you enroll yourself, you register to participate on a study, so it must be sound. But if you just receive some links or from random phone calls to participate in a study, it's flawed. All right. Let's see what you're gonna say about each of these. We said that in a survey of 1,368 subjects, the following questions were asked on the USA Today website. In your view, are nuclear plants safe? In a sub in a website, they just ask the question, not directly to the survey subjects were in internet users who choose to respond to the question posed on electronic. So it's really voluntary, right? So this survey is a voluntary response sample and has strong potential to be flawed. So we said if it's voluntary, then it would be flawed, right? Now, researchers at Yale University, that's number two, conduct a right study of clinical trial by using subjects who volunteer after reading advertisements soliciting paid volunteers. So this one also this approach, what would you say for that one? So the samples have really voluntary response samples, right? And have potential to be fraud again. So I think this one, remember, you register as volunteer. It's not like a required, but this approach might be necessary due to ethical considerations involved in randomly select subjects and somehow imposing treatment on them. So all depends. Some people might even say it's a sound, but at this point, it's flawed. In a password number three, in a password bust survey of 2030 randomly select adults, 39% said they never share passwords with anyone. You see this one? It should be sound because they pick up those people, they participate, and they know exactly the number of people who participate in this one. In a survey of social media usage, the Pew Research Center randomly select, you see, randomly select adults in the United States. Again, this study is sound because you know exactly how many people would participate. It's not voluntary response samples, right? So hopefully you enjoy these examples and you have time to continue. But now, everything we just did is the first part of statistical and critical thinking, the first part of the process. We did preparation where we talk about context, source of data, and sampling method. Context, what do the data represent? What is the goal of study? Source of data are the data from a source with a special interest, and sampling methods, would that be biased or unbiased? Now, I think you're ready, after example number three, to go with, some number four, sorry, to go with the second step in the process after preparation, we're gonna begin with to analyze the data. So after completing our preparation by considering the context, source of sampling method, we begin to analyze the data. Let's analyze the data. Graph and as we said, in the chart we do, the first step of analyzing the data, we need to graph and explore, right? And analysis should begin with appropriate graphs and exploration of the data. We should apply statistical methods. So, because what we need to understand in this one, a good statistical analysis does not require strong computation skills. A good statistical analysis does require using common sense and paying careful attention to sound statistics methods. That's something we need to pay attention to. Knowing the computer is good, but if you don't have computer as well, you can use common sense and it's kind of like it. The third, as we prepare for it, after we do that, the final step in our statistical process involve also conclusions. The final step in our statistical process involves conclusions, and we should develop an ability to distinguish between statistical significance and practical significance. Let's see. Statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. All right? Hopefully you remember that. We can say, oh, getting 98 girls in 100 random birth is statistical significance because such an extreme outcome is not likely to result from random chance. Get, you know, you have 100 births and you want to obtain 90 out of 100 to be girls, this outcome is not likely to result from random chance. So getting 52 girls in 100 births is not statistical significance because that event could easily occur with a random chance. You need to see which one is statistical significance is when there is no chance. I mean, the chance to obtain it randomly is very low, but it's not statistical significance if there is a chance to obtain it, at this point. Practical significance, we said statistical significance and practical significance. So an outcome can be statistical significance and it may or may not be important, So don't associate like statistical significance with importance. So that's very important to verify, to analyze. How about practical significance? It is possible that some treatment or fighting is effective, but common sense might suggest that the treatment or fighting does not make enough of a difference to justify its use or to be practical. So what we mean by that, as we said, it's not possible. It is possible for some treatment or fighting to be effective, but you know what? Common sense might suggest that the treatment or finding does not make enough of a difference, right? So we can see, for example, in the trial of weight loss programs, it all depends on how many people you would select to study the weight loss. Sometimes it may not worth the time, cost, and effort to make it happen. So this when you do that, probably it's not going to be practical significance because, common sense can show you, what, you try to do this, but I'm pretty sure it's not working because it's not like only tell people to lose weight. There should be a long process and very organized plan methods for it. That's not include only exercises, it's, habits, in diet habits. It's also important. All right. Now we have gone over the three steps of preparation, analyze the data, and also conclusions in the process of running a statistical and critical thinking, and you understand the statistical significance and practical significance, how about we review it in a few examples very quick because we have a very few examples that we can look at together. Determine whether the results appear to be statistical significant and also determine whether the results have appear to be to have practical, statistical significance and practical significance. I strongly advise you to review the notes if for some reasons you still see it's difficult to do. All right, let's go over, oh gosh, I think these data, you know, all right, we're gonna go over this analyze later. Let's do this examples number five. Examples number five, number one in five, in a study of the Ornish weight loss from program, 40 subjects lost uh, a mean of 3.3 pounds after 12 months based on data from comparison of Atkins Ornish Watchers and zone diets for weight loss and heart disease risk reduction by Daniel Denzinger and al. That's a journal, it's appeared in the Journal of the American Medical Association, volume 293, number one. So methods of statistics can be used to show that if this diet had no effect, the likelihood of getting these results is roughly 3 chance in 1,000. That would be less than 5%, right? So what we say, the Ornish was the Ornish weight loss program has what? Practical or statistical? Because we just said it with the statisticals. If you have, is achieving in a study if the likelihood of an event occurring by chance is 5% or less. Three out of, you see, you have three out of 1,000. So what would you say for this one? Yes, statistical significance. So let's say this one right here is statistical significance. Hopefully you can read my handwriting. I'm terrible with that. So what we mean, has a because the results are so unlikely. 3 chance out of 1,000 to occur by chance. It does not have practical significance because the amount of lost weight is very small, right? 3.3 at this point. So now let's see another one. One you know, one of the Gregor Mendel's famous hybridization experiments with peas yield 580 offsprings with 152 of those peas, or 26%, having yellow pods. According to Mendel's theory, 25% of the offspring peas should have yellow pods. So is it statistical or practical? The difference between Mendel's 25% rate and the result of 26% is not statistically significant because according to Mendel's theory, 146, is that 100? Yeah, 25%. Yeah, 126%. Yeah, 146 of the, when you take 26% of it, 145 of the 580 Ps would have yellow pods, but the result consists of 152, all right? Peas with yellow pods. So the difference of 7 peas with yellow pods amount the 580 offspring does not appear to be statistically significant. The difference does not appear to have practical significance. So it's neither one, right? So that's what happened when you analyze the data, you would realize it's not working. So it's kind of a neither one. So the difference does not appear to have a practical significance as well. So we would say this one is neither, right? Now let's see for the last one. We're gonna go with the court clerk in Essex County, New Jersey, was responsible for randomly assigning the order in which candidates' names appeared on a recent election ballot. Among 41 different ballots, a Democrat was placed on the first line 40 times, and a Republican was placed on the first line once. Well, yes. So with 40 well, with 40 out of 41 ballots having the Democrat first, it appears that the result is statistically significant because of the great advantage enjoyed by Democrats. The result also have practical significance, right? So it's mostly statistical significance. Statistical significance. It's all depends where you find your sin, because 1 out of 41 is less than 5%, right? So it's all depends where you are. So use these examples so you can do more. You can review and do more exercise from the book or on Pearson, because all assignments would be covered on Pearson's. That's where you need to complete all assignments. Um, you know, we have time to go in this video over on how to analyze, right? We should be careful when, analyze data. One, a few items that could cause problems when analyzing a data, because we need to verify that. We should be very careful to avoid the mistake of thinking that those some small differences have practical significance. So, let's analyze it. So, what's could happen? Misleading conclusions. When forming a conclusion based on a statistical analysis, we should make statements that are clear, even to those who have no understanding of statistics and its terminology, because you really need to be clear on what you're doing on this. So you won't mislead anyone. Sample data reported instead of measure when collecting, um, you know, if you want to go a little bit further on the first one, what we mean by forming a conclusions, we said when forming a conclusion based on statistical analysis, we should make statements that are clear, even to those who have no understanding of statistics and its terminology. We should really careful avoid making statement not justified by statistical analysis. For examples, you would see in this book, we would introduce the concept of correlation or association between two variables, such as shoe print length and height of males. So that's what we just did in the previous example. Or association between no, sorry, a statistical analysis might justify the statement that there is a correlation between shoe print length and height, but it would not justify a statement that an increase in the shoe print length causes an increase in height, right? Such a statement about causality can be justified by physical evidence, not by statistical analysis. So I know I tell you a lot of things just to explain what misleading conclusions can bring us to. So sample data reported instead of measured, you know, so when collecting data from people, it's better to take measurements yourself instead of asking subjects to report results. So you cannot ask subjects to report, so do it yourself. Okay, that's very important. Ask people what they weight instead of you are likely to get the desired weights, not the actual weights. Because if you ask people how much you weigh, they're gonna tell you whatever they want to, because that's what they want to see here. But if you come with your balance and ask them step on this one and you can take it better. People tend to round, usually round down, right? Sometimes way down when ask someone with a weight of 187 pounds, for example, my response that, oh shit, you could say, oh, yeah, 160. They actually the balance is 187. They would say 180 or maybe 170 or 160. Accurate weights are collected by using a scale to measure weights, not by asking people what they weigh, right? Load questions. If survey are not worded carefully, the results of study can be misleading, right? Survey questions can be loaded or intentionally worded to elicit a desired response, right? Uh, Here are the actual weights of yes response for the two different words of a question, for example. I can give you something like that. So 90, 97% yes. Should the president have the line item vetoed to eliminate risk? 57% yes. Should the president have the line items veto or not? So you see, it's two different questions because it's two different questions, and actually, it's gonna take it's two different questions. We will see. Now, next steps on analyzing data potential pitfalls, this is misleading. Um, Order of questions. Sometimes survey questions are intentionally loaded by such factors as the order of the items being considered, right? I would say, would you say that traffic contributes more or less to air pollution than industry? you know? Or would you say that industry contributes more or less to air pollution than traffic? It's all depending which order you want to put them, and it's going to make a lot of sense, right? Confusions also. Let's go about the nonsense because the nonsense occurs when someone either refuses to respond to a survey questions or is unavailable. When people are asked survey questions, some, you know, firmly refuse to answer. The refusal rate has been growing in recent years, partly because many persistent telemarketers try to sell goods or services by beginning with sales pitch that initially sounds as though it is part of an opinion poll, right? So, that's very important to see about the non-response. So if we go also about low response rates, if a survey has a low response rate, the reliability of the results decrease. In addition to have a smaller sample size, there is an increased likelihood of having a bias among those who respond. About the last one we can see is the percentages. Some studies cite misleading of unclear percentages. Note that 100% of some quantity is all of it. But if there are references made to percentages that exceed 100%, such references are often not justified because, you know, um, if an advertiser claims that your utility costs can be reduced by 200%, that claim is misleading, How can your utility bill be reduced by 200%? Because 100% is already, you don't owe any money. 200% is like you're gonna send your money. Eliminating all utility costs would be only 100%, right? It doesn't make any sense to reduce it by 200%. So that's very important to verify those before we're gonna do another few examples by just you know, analyzing. I'm gonna come back in a different video just to do the last exercises because we have three of them. You know what? How about we go very quick on these examples and conclude because I'm hoping we can save with no problem later. Exercise number 6, it says in a survey. Okay. Ines, here we're gonna just respond about percentages and make it very easy to answer. We said in a survey, Conducted by Opinion Research Corporation, 1,000 adults were asked to identify what is inappropriate, uh, uh, you know, what is inappropriate, in a survey of 1,000, adults were asked to identify whether it's inappropriate in the workplace or, okay, whether it's appropriate to identify what is inappropriate in the workplace. Of the 1,000 subjects, 70% said that miniskirts were not appropriate. Now, it tells you 70% out of what is 70% out of one. Remember, what is what? What is the question mark? Is mean equals here. 70%, let's say 0.70 of mean multiplication 1,000. So 70% or 70% of 1,000, all you have to do is to take zero point 0.7 times 1,000, and that would give you what? Again, 700 adults, right? All right. So what is inappropriate in the workplace? So 70% says it's miniskirt. So 700 out of 1,000 people says that. So among, we can also ask these questions with no problem because they ask you what is inappropriate. We're gonna go with B. Among the 1,000 respondents, all right, 550 said that short are unacceptable in the workplace. What percentage? Now you're looking for the percentage. What percentage? Okay. What percentage is what percentage of of 1,000 is, you can translate it, translate it into words, is 550. So percentage of, let's say it's P, of mean multiplication 1,000 is 550. Now, if you want to solve for P, you divide each of them by 1,000 like this. So percentages would be 550 over 1,000. So when you take 550 divided by 1,000, it's gonna give you 55%, right? 55 is 0.55, or you're gonna say it's 55%. Okay? So that would be the answer. You can you can translate words in mathematical expressions, or you can transfer mathematical expression into words, right? So that's an English sentence, right? There should be no problem with it. You can translate numbers to percentages, percentages to numbers, right? If your bills, you can identify what percentage of your income represents your bills. Okay, would be used for your bills. Number seven, we have so many examples we could do. In a survey conducted by the not.com, 1,165 engaged or married women were asked about the importance of a bended knee when making a marriage proposals. Among the 1,165 respondents, 48% said that the bended knee was essential. So, what is the exact value? So, what is the exact value of this? So, what is the exact value that is 48% of mean multiplication 1,165 is equal. So all you need to do is multiply 0.48, okay, 0.48 times 1165. I'm sorry about that. We said this one, 48%, that would give you, uh, for this one, 559.2 respondents. So, but the problems, you should always round up. So if you want, when you find a 559.2, you can always round it up to 560. But in Pearson, because you need to be very specific with Pearson, sometimes it's better you leave it as they ask you. Um, could the result from part A be the actual number of survey subjects who said that a bended knee is essential? Why or why not? So, no, because the result is a count of respondents among the 1,160 engaged or married women who were surveyed. The result must be a whole number, right? So the result must be result must be a whole number. We're talking about people, right? We cannot have a decimal then. The result must be a whole number. What is the actual number of survey response saying that the bending knees is essential? You can even go with 559 or 560, but let's do 559. So 559 respondents because we are pretty close. But usually for people on a survey, the sample size is better you round up. Among the 1,165 respondents, 93 said that a bending knee is corny and outdated. What percentage? Percentage of 1165 is 93. So if you divide both sides by 1165, you would find that percentage to be, you do the 93 divided by 1165. So answer would simply be, 0.07898. So it's better we round it to 8%, right? So 8% of respondents said that the bended knee is corny and outdated, right? Last examples looks the same. I usually leave the last one for you to enjoy and have fun. And you let me know if you have any questions. Do not hesitate. Try the last number and answer those questions because it's still the same thing. You need to convert decimal percentage to whole numbers and whole numbers to decimal. In a different video, we're going to come back with section 1.2, types of data. Hope you enjoyed this one and let me know if you have any questions. Take care.